Today, I will be answering 3 problems from Chapter 9.
First problem. An electric fan is turned off and its angular velocity decreases uniformly from 550 revs per minute to 210 revs per minute in a span of 4.4 seconds. A. Find the angular acceleration in revs and the number of revolutions made by the motor in the 4.4 second interval. B. How many seconds are required for the fan to come to rest if the angular acceleration remains constant at the value calculated in Part A? So A. Find the angular acceleration in revs and first, in order to do this, we must first convert the revs per minute to rads per second. So 550 revs per minute, our initial angular velocity will become 57.59 rads per second. And 210 revs per minute, our angular velocity after the 4.4 seconds will become 21.9 rads per second. We then subtract the initial angular velocity from the final angular velocity and divide it by time to get the acceleration. The acceleration we got is negative 8.09 rads per second. Then we must get the number of revolutions made by the motor in the 4.4 second interval. To do this, we have the formula 1/2 angular velocity final plus angular velocity initial times time. So we just plug in the values and we get 27.8 revs in the span of the 4.4 second interval. Now for B. How many more seconds are required for the fan to come to rest if the angular acceleration remains constant at the value calculated in Part A? So in order to get the time required until the angular velocity is at 0, we have to get the final remaining angular velocity, which is 21.99, and divide it by the angular acceleration, which is negative 8.09 rads per second squared. Doing this, we will get the answer 2.71 seconds until the angular velocity of the fan is 0. Problem 2. In a charming 19th century hotel, an old-style elevator is connected to a counterweight by a cable that passes over a rotating disc 3 meters in diameter, and the elevator is raised and lowered by turning the disc, and the cable does not slip on the rim of the disc but turns with it. At how many RPM must the disc turn to raise the elevator at 20 centimeters per second? So the formula for angular velocity is linear velocity over radius. So our linear velocity is 0.2 meters per second over a radius 1.5 meters, which will give us 2 over 15 rads per second or 0.01396 RPM. B. To start the elevator moving, it must be accelerated at 1 over 8g. What must be the angular acceleration of the disk in rads per second squared? The formula for angular acceleration is just linear acceleration over radius. Given that the linear acceleration is 1 over 8 g or 9.8 over 1.5 meters. This will give us an answer of 0.8166 rads per second squared or 112 g rads per second squared. C. Through what angle, in radians or degrees, has the disk turned when it has raised the counterweight elevator 3.3 meters between floors? The formula for angle is just arc length over radius. Given that the arc length is 3.3 meters and the radius is 1.5 meters, plugging this in, we will get the answer 2.2 rads or 126.05 degrees. Problem 3. An airplane propeller is 1.73 meters in length tip to tip with a mass of 109 kilograms and is rotating at 2,500 rpm about an axis through its center. You can model the propeller as a center rod. A. What is its rotational kinetic energy? So the formula for kinetic energy, rotational, is 1/2 moment of inertia times angular velocity squared. So the moment of inertia of a slender rod axis through one end is 112 mass times length squared. Plugging this in into the formula and then plugging in the values will give us an angular kinetic energy of 931,334.58 joules. B. Suppose that due to weight constraints, you had to reduce the propeller's mass to 75% of its original mass, but you still need to keep the same size and kinetic energy. What would its angular speed have to be in RPM? Rearranging the previous formula to give us the square of the angular velocity, we have to divide the kinetic energy angular by 1/2 of the moment of inertia. This will give us 91,355.98. We need to square root this to get the angular velocity. The angular velocity is 302.25 rads per second or 2,886.27 rpm. Thank you for listening.